Hello, everybody. We will start in a minute. Just asking for some patience, but yeah, now the clock turned 2 o'clock, and we only have 1 hour for this session today. A very warm welcome to all of you to today's webinar, and happy for your attendance around industrial connectivity and for successful migration to Industry 4.0. Very happy to have some speakers today joining me, very experienced colleagues actually in that domain. So pretty pleased to have that joint session today, and yeah, hopefully ask some questions and raise answers towards questions around connectivity, industrial digitalization, and how to move forward. So first, quick introduction around me. Who am I? My name is Andreas Hoffmann. I'm Director of Business Development at SMARTUNIFIER, and today I will also take care a bit of connectivity, but in another sense, as bringing you all together and exchange about the bespoke topic, industrial connectivity, digitalization, and really looking forward to that joint discussion that we will have today with our attendees of this webinar. Some organizational topics later on, but feel free to use the chat functionality during the webinar, raising some questions. We will pick them up either during the session or at the end. So let me give you a brief overview about our today's speakers, and I'm very happy to have them on board. As said, we have Ingo Müller, the head of Tribe Innovation Management at T-Systems. We will have also Dave Thielert on board, Senior Strategic Partner, Development Specialist IoT from AWS, and as well Dr. Frank Fraunhofer, the CEO of SMARTUNIFIER. A very quick look to the agenda that we will follow today. And as you have realized, we already started with the introduction to the webinar. And after a few more words from my end, I will hand over actually to Dave, and looking at the role of cloud and cloud platforms for provisioning the advanced industrial ID use cases. We are going to talk about some of them later in the session. After that, followed by Frank Fraunhofer, and actually getting down a bit to the essentials of connectivity, how to connect edge devices, equipment, and a way to integrate them quickly and easily towards on-premise and cloud IT systems. And finally, we will have Ingo talking about a specific use case, and I'm very happy actually that Ingo picked this up for our webinar today, looking at energy monitoring, which is, I think, a crucial topic these days, and how this is enabled by sophisticated connectivity and data processing. As already mentioned, we will have a Q&A session at the end. Very welcome to all of you to use the chat functionality. We will pick questions up and raise it then at the end towards the speakers. So a few more words about some key elements of industrial connectivity and why we are having that webinar today. I think Industry 4.0, Airport 4.0, however you call it, and I know there are some colleagues from the aviation industry joining today as well, is very much requiring a network around communication. Communication of everything actually towards everything. So things need to be connected to be better shared information between assets, between systems. And in that context, we've seen a significant increase in the last years, actually, with the availability of data through different trends in the digitalization domain, machine learning, AI, edge computing, and cloud platforms as well, that give us access to data, but also that require data actually to be consumed. And in that context, we all know a lot of industries out there, including aviation, is not greenfield. Yeah, we're talking about brownfield environments, which also concludes that data is there, but in various forms, and at different levels within the enterprise, and it is absolutely crucial actually to gain benefit from that to implement seamless and decentralized secure connectivity. So with that in mind, actually, we are looking at how to unify data, providing in real time a vertical and horizontal interoperability between systems and components, which we see as a core element actually of all digitalization activities to establish this type of connectivity. Now, with having said that, we will start with our first session today, and very warm welcome to Dave from AWS. Dave has spent the last decade actually in developing IoT initiatives for a wide variety of use cases, ranging from classical throughput optimization to commercial building efficiency or maritime shipping fuel efficiency. And prior to AWS, Dave has already built collaborative partner ecosystems with GE, Hitachi, to help industrial leaders solve digital transformation challenges. Today, Dave leads the global manufacturing initiative with AWS partners, leveraging AWS IoT services to solve vertical specific challenges and deliver value for the line of business customers. So he received his MBA from the state of Ohio University and is based in Cleveland whenever he's not traveling, and I think that's quite a lot. So I'm happy to have you on board, Dave. Please share your screen, share your camera, and the floor is yours.
All right, thank you so much for that introduction, Andreas. Can everyone see my screen? Are you able to see the first slide? Just quick check before I get into things. I'm going to assume that's a yes.
Yep.
Great. So hi, everyone. My name is Dave Thielet, as Andreas mentioned, and I'm extremely grateful for the opportunity to speak to all of you today alongside some of these tremendous partners for AWS, namely Amorph and T-Systems. I'm going to kick things off and sort of open the discussion today talking about some of the technologies that form the backbone of a digital transformation and Industry 4.0 or Airport 4.0 story. And I'm going to share a few customer examples as I do this. So let's dive in. Before we get into those case studies and some examples, I want to set a bit of context here. You know, we're in the midst of what's called the fourth industrial revolution, where data is really sort of the new oil, so to speak. More and more industrial, commercial, other type of organizations are harnessing the power of data that can be monitored, measured, and analyzed to drive improvement and insights in their operational processes. On the right-hand side, you'll see this continuum that we have seen customers on over the past several years. And I think over the last particularly 20 or 30 years, most of the analysis has been focused on that lower left-hand corner, where you're looking at what happened and why did it happen. And a lot of this is driven by constraints around the amount of data that can be processed or stored in an on-premises kind of fashion, or in a host, a data center that's being managed by that organization. Typically there's a lot of manual processes to extract, coordinate, and analyze the data that are coming out of various processes. And what we've seen is, with the introduction of cloud computing, something that has been in place on maybe the IT side of the house for a while now, but we're seeing more and more our line of business customers on the OT, or the operational side of the house, starting to realize the power of the cloud in being able to store and analyze near infinite amounts of information and complex analytics, and using the data to model operations and start to even predict their outcomes. Just before I get into things too, from an AWS perspective, our focus here is these are some of the key segments that we work on, where we see different technologies like cloud computing, IoT, and advanced AI ML analytics that help customers with their optimization of their business by growing revenue, cost, or reducing risk. Growing revenue can be achieved with faster times to market, or optimized marketing strategies, or creating new revenue streams through smart products or service capabilities. Lowering cost obviously can take the form of cost reduction in infrastructure, reducing water, air, gas, electricity, steam expenses, or reducing production costs by improving the machine or worker productivity, machine availability, or product quality. Our definition of industrial is pretty broad and includes, manufacturing and other types of activities from a variety of verticals, as you see here, such as, but also things like, healthcare and life sciences, automotive, obviously travel, and, transportation falls into that category as well. Why are customers starting to move towards the cloud? And I think, in addition to those kinds of improved operations that we're seeing there's a variety of other types of drivers. Some might have compelling events like COVID over the last few years and the need to remote monitor critical infrastructure, while others simply want to get out of maintaining their data centers and having to deal with things like end of life for hardware and software. Board of directors expect more than just cost savings and efficiency. And even though customers are achieving things like 25 to 50% savings with a cloud provider like AWS versus doing their own data centers and having to have those total cost of ownership, still customers want to be able to move faster and transform their own customers' experiences. They want to deliver digital transformations and modernize their businesses. And they want to reinvest those cost savings to drive new innovations and business models. I think here just a couple of the top line benefits of moving to cloud computing that we see, and this is based on the different migrations and modernizations. Migrations would be moving something that you already are doing in a data center and just simply moving it to, an AWS cloud environment. Yeah, I think, there's an angle here of pure cost savings. With the ability to reallocate resources from simply managing that data center to add more value added activities. And then we also see, perhaps somewhat paradoxically, we see a reduction in things like security incidents with that 43% reduction, simply because, you're no longer having to manage both the physical and digital security yourselves, which is something that we at AWS specialize in, so that allows us to have a little bit of a differentiation there. All right, I want to talk a little bit about an airport example here, and some of the challenges that we've had that some of our partners, for example, tasked the Cincinnati airport to deal with. Two sort of use cases that TaskWatch tackled for the Cincinnati airport. The first is that this is an airport that historically was a hub and was moving to an origin destination. And that meant that their actual traffic, so if you think about a hub airport, about 80% of the traffic, give or take, is going to be moving through the airport, coming from one plane and then getting on another plane, versus an origin destination where you have a lot more passengers coming from their homes and getting to the airport and then leaving or returning to that airport and then heading home, which significantly, basically doubled the increase of passenger drop off and pickup. So the traffic was something that they were struggling to deal with in terms of improving the airport experience for their customers. And what TaskWatch was able to do is utilize some of the newer AWS artificial intelligence and machine learning services to analyze video camera feeds to understand how long certain vehicles were waiting in different areas of the passenger and drop-off locations for departures and arrivals. This enabled them to be able to alert airport security and other staff to help move things along. And you see on the right-hand side, 12.8 messages an hour, essentially, where a vehicle is spending too much time in those loading zones. So helping improve that traffic flow, which improves that customer experience. The other thing that they were able to look at is, if you think about the tenants and the different airlines for the airport and the operations that take place when an airplane lands or is getting ready to take off, and that time that's they're refueling, they're restocking things on the plane, they're cleaning the airplane, they're loading the baggage, all of those activities. Those ground crews are third party typically, at least in the United States, third party crews, and being able to, with again computer vision, look at what are they supposed to be doing, what are the tasks that need to happen still, providing alerts, basically helping to automate those activities for the ground crews so that they're able to help ensure that the planes arrive and depart on time. I think these are just some interesting examples. Again, going back to the messaging around connectivity and the cloud computing aspects of this. You can't get to these analytics without having a system in place that allows you to tap into those camera feeds to analyze the data that's being seen in those in near real time, and to be able to then action based on that, close the loop in order to address those problems. So what else are we seeing? As I'm going to shift gears a little bit into more of kind of industry and manufacturing, I think we're seeing that the customers move to the cloud in this with a few different patterns that we're starting to see now. I think traditionally you would have had, in a manufacturing context, a very monolithic pyramid where you may have some sensors and actuators on equipment on the shop floor, moving to a PLC, moving to IT systems like ERP systems or MES systems, that there's a pretty clear distinction between what's considered OT systems, or the operational systems, and the IT systems. What we're seeing today is that, in addition to cloud computing having revolutionized the IT part of this, there's a growing convergence of this OT and IT data in a hybrid way, where customers are looking to connect these systems more flexibly in order to address various operational use cases with new data sets. Customers we're working with want that data transparency, the ability to see assets at a granular level and make data-driven decisions. And we're seeing customers looking to create with partners rather than vendors, domain experts in the space that can effectively utilize newer technologies like big data, AI, ML, applied to those industrial challenges. Here are some of the most common use cases that we find in customers that are trying to address these newer technologies and architectures. Manufacturers and other industrial customers are stressed in a variety of ways to do more with less in their operations. And in that sense, cloud computing becomes a tool to unlock solutions for these use cases. We see a lot of activity in improving the utilization of assets and prevention of unplanned downtime with machine monitoring, for example. Another major use case and potential benefit that we see customers gravitating towards are things around product quality. And this can take the form of, catching defects before they leave the shop floor, or ensuring, for example, we have one customer who deployed a solution that does quality inspection to reduce scrap in their process, and it also resulted in a reduction of spurious warranty claims because they now had documentation around the production aspects of a particular item that they could go back to and say, no, this left our facility in good quality. Here's the record of that. Here's the image showing it. And so they saw a reduction in warranty claims by 5%. we also see things like worker safety being very important, especially with COVID, but also in classical sense of prevention of accidents, improving productivity and monitoring things like employee tiredness and things of that nature. As you might suspect, AWS or Amazon knows a lot about supply chains and supply chain resiliency and costing out in that process. We and our partners leverage the cloud and its ability to scale up computing capabilities to aid in forecasting and other cost reduction efforts. And lastly, we see customers leveraging cloud technologies to build new business models. For example, being able to sell smart products to other customers and monitor those to address things like warranties and SLAs to improve their service levels. In the real world, most companies, when they try to implement these things, realize that it's great, it's a simple concept, but often it's very complex. And I think Andreas alluded to some of this earlier on in terms of the complexity of different things you'll find in an industrial or airport or other type of setting. Most customers need to be able to connect a variety of different systems to make, and this is where partners like Amorph really help, to move data around and interoperate with the different systems. And that's something that's absolutely critical to addressing the business challenges that we've talked about in some of those use cases on the previous slide. I think a great example of this, and it ties into some of the work that Amorph has done, is with Volkswagen, where they have built their digital production platform on the AWS cloud. They use that platform and the associated services to cover a variety of use cases that you see on the left-hand side, such as asset discovery, downtime correlation, scrap reduction, etc. One of the things that they tout is that 30% efficiency gains, and those use cases ladder up to those types of gains. In specific, with Amorph, they're helping them realize efficiency gains via an application that they've deployed at one of the Volkswagen final assembly plants. I believe the application is called the Road Test Predictor, and basically prior to leaving a manufacturing plant, the vehicle would normally have to undergo a road test to ensure the quality of it. But because of the power of some of these technologies that we're talking about, Amorph has built an application that allows them to analyze over 10,000 different vehicle attributes, such as the torque that's applied to a certain lug nut or the amount of time the car spent in the paint shop. And in so doing, they're able to accurately predict over 97% with 97% accuracy when compared to the actual road test, whether or not that vehicle is likely to pass. And by so doing that, they're able to advise an operator if that vehicle could actually skip that road test process and save a few minutes, which over the course of a production schedule can be a tremendous amount of savings by moving on to the next station without the test. This is one of those big improvements that VW touts as a way to improve their operational efficiency. But core to all of that, remember I said over 10,000 data points, is the ability to actually connect into those OT and IT systems that is really empowering that effort. The last thing I want to talk briefly, and I think we talked about a little bit more, things like sustainability, energy, being good corporate stewards, and we see this being a common trend as well amongst our customers. We look at sustainability at AWS in two lenses. One is the sustainability of the cloud. And you can see, one of the things that we looked at is what does the carbon footprint look like for an AWS data center or data cloud capabilities versus those that a customer might be running themselves on-prem, and seeing that because of our efficiencies, the processors that we use even down to that level in our servers, we see an 88% lower carbon footprint. The other angle that we look at sustainability through is sustainability through the cloud, and this is using those different services and cloud technologies that I've mentioned, AI/ML, to enable our customers and our partners to create applications that allow them to achieve their energy results. And so this can be done by, running equipment more efficiently by analyzing how that equipment is being utilized. So these are kind of two ways that we look at sustainability, and I'll just close out with one more case study from another partner on some of the diverse benefits that I think cloud computing can bring in one kind of instance. So TrendMiner is one of the partners. They're based out of Belgium that we work with, and they do cloud analytics on AWS with various different data sources. They worked with a major chemical company who was targeting sustainability initiatives and had a continuous improvement goal, and wanted to transform their organization further by making each employee, even down to that operator level, empowered with cutting-edge data analytics to better do their jobs. So what did TrendMiner build? Well, the focus was around a batch processing scenario. And because of some of those AI/ML analytics and the different data streams that were being brought into AWS, which could be done through partners like Amorph, TrendMiner was able to democratize that data for the operators and unlock the efficiencies that you see on the right-hand side. So, an improvement of 1 extra batch per day, while at the same time reducing the consumption of energy by 9%. And this led to an overall 5% increase in revenue. I think the last thing I want to point out is that because this was a cloud-based solution rather than an on-prem with a data center, the deployment, the rollout to those additional sites that they've now started to do was reduced by 30% the amount of time that it would take just to implement the new solution. And in real world terms, that meant they were able to do over 20 new locations of their factories per year with that rollout. So, really powerful, and I think it shows sort of the multifaceted benefits that the connectivity and cloud computing can bring to various different customer scenarios. We've talked about an airport, we've talked about an automotive manufacturing facility, we've talked about a chemical processing facility. I'm now going to hand it over to Frank to talk a little bit more about the Amorph solutions, but I appreciate everyone's time. And go ahead, Frank, I'm going to hand it over to you now.
Just maybe first briefly, let me thank you, Dave, for these insights and some quite impressive results you've shown. Thanks for that. I personally like the aviation examples for sure.
Sure.
But
that's probably the most advanced too. If you think about the computer vision use case that those are, it's really advanced stuff.
So we'll come back to that actually at the end, also during the Q&A, and raise some questions around that. And as you already said, I would like to hand it over now to Frank, Managing Director of Amorph, and actually one of the co-founders of Amorph Systems and responsible for overall development operations. Frank has actually also vast experience in the industrial domain, coming originally from the Research Institute and just by coincidence a similar name from the Fraunhofer Institute in Germany, and has worked for a lot of manufacturing logistic companies actually. So I'm more than happy, Frank, to hand it over to you now to look a bit deeper into the connectivity aspect, and please go ahead and share your screen.
Hi, so now it's my turn. Thanks, Andy. I hope everybody can see the screen.
Yes.
And thank you, Dave, for your very exciting intro into AWS cloud computing platform and the shown examples, which already gave an impressive overview of the possibilities and business benefits modern IT landscapes are bringing to the users. I too would like to extend a warm welcome to my presentation. Efficient connectivity to edge devices and the way to integrate them quickly and easily with on-premise and cloud IT systems. So first, I want to give you a quick overview of Amorph Systems. Then in my talk, I'd like to illustrate firstly some main challenges for the integration of industrial devices with upper-level IT systems, either being positioned on-premise or within the cloud. In this respect, I will introduce you to Amorph's integration platform SMARTUNIFIER as a tool to enable seamless connectivity between all communication partners on OT and IT level. Some words about Amorph Systems. Amorph was founded in 2013 with a clear vision to develop and provide the best IT products and services to its customers for integration and operation of complex logistics systems, like, for example, production facilities. This vision of Amorph is represented by our company's slogan, transform data into value. Amorph is based in Germany and Romania. We also have business offices in Atlanta, US, as well as in Japan to specifically serve our US and Asian-based customers. With Amorph Systems, we address two business domains, which are the manufacturing industry, specifically Industry 4.0, as well as the airport traffic industry. Many well-known customers trust our products and services. Within the manufacturing industries, our airport solutions are used within more than 30 airports worldwide. Amorph is steadily working to build up a strong ecosystems with partners, including technology partners like AWS and others. Especially, we are very proud to become fully onboarded as one of the first partners for Volkswagen Industrial Cloud, and now being able to provide SMARTUNIFIER as powerful OT/IT gateway for various car manufacturing use cases. Our journey begins with today's situation of industrial devices and IT systems connectivity. The situation that we currently face in real life is like illustrated on the shown slide, and the ones of you that might deal with some topics like integration of IT systems or industrial connectivity should be very familiar with that kind of picture. The main problem when someone wants to integrate industrial devices is that each and every device or equipment typically talks a different language in a sense that it uses different communication protocols and formats like files, databases, direct PLC connections, or various message bus systems. More modern equipment, meanwhile, provides OPC-UA-based communication channels, which are easier to use, but still don't eliminate the high heterogeneity regarding shop floor connectivity. Likewise, the upper level Fab IT applications, so for example, MES, SCADA, ERP, and so on, provide different IT interfaces. As well, these systems communicate with nearly all kinds of communication channels today IT technology provides. As well, message bus systems, databases, and files with different formats are widely in use. Consequences regarding the device and system integration are poor scalability and performance, limited scope regarding the location where interfaces are being operated, difficult data exchange between IT systems due to missing data semantics, high effort and cost due to complex IT landscapes, limited reusability of interfaces across different devices and IT systems. In general, we face two major requirements for enabling powerful IIoT connectivity. First of all, of course, this is multiple protocol support out of the box to achieve fast integration times and minimized efforts and cost. The platform is required to support many southbound and northbound protocols and formats as required for typical industrial use cases. Secondly, the platform shall require only a minimum of coding to make integration processes as simple and fast as possible. By combining low-code graphical mapping with data semantics, data can be exchanged very easily between different target systems. The platform needs to be applicable for very small, that means maybe just connecting one single equipment, up to very large infrastructures consisting of hundreds or even thousands of communication partners. To still be highly performant, even within large infrastructures, a decentralized architecture is required, and any kind of central architecture like central message bus or databases should be omitted. Nevertheless, for high reusability of the implemented interfaces across the whole enterprise, a central configuration of interfaces and central deployment and operation control is required. This illustration shows the basic functional architecture of an advanced connectivity platform by the examples of Amorph's product SMARTUNIFIER. The given example shows a basic architecture for an industrial manufacturing use case. With SMARTUNIFIER, you can easily connect any number of communication partners like devices, equipment, upper-level IT systems, and of course, as well, cloud-based applications. To enable communication between the various communication partners, SMARTUNIFIER supports a big variety of different communication protocols like files, databases, OPCOA, different middlewares like MQTT, and connectors to many FAB and enterprise-level applications. Likewise, a similar architecture can of course be applied with SMARTUNIFIER for airport industries, which in principle, from a pure data perspective, are not differing significantly from manufacturing domain. Of course, IoT devices are different. Instead of production equipment, there would be connected scanning equipment, escalators, sorters, and more. Instead of manufacturing execution systems, we might have to connect airport IT systems like AODBs, passenger flow monitoring systems, resource management systems, and others. One unique feature of SMARTUNIFIER is that it drastically simplifies the way how connectivity is implemented. Therefore, it does not require to program interfaces anymore in a manual way using complex programming languages. Moreover, it applies a graphical and low-code based way to define so-called information models that hide the complexity of a communication protocol and allow a mostly graphical configuration of interfaces between different communication partners. The big advantage of this approach is the simplicity, since it is not required anymore to know the technical handling of the detailed communication protocols below. In other words, it does not matter anymore if a device is connected via PLC, via OPCOA, or any other industrial protocol. All are handled the same. Another very unique thing about SMARTUNIFIER is its technical system architecture, in terms how SMARTUNIFIER is being operated and how a SMARTUNIFIER installation is managed. Very important to know is that SMARTUNIFIER is not a central and complex to handle message bus, nor does it contain any central database where all communication partners are attached to, and which might become, at some point of scale, a serious bottleneck in terms of capacity, performance, and reliability. SMARTUNIFIER works different. SMARTUNIFIER is based on a fully decentral system architecture using container and cloud technologies for virtually unlimited scalability. Instead of having a central message bus, SMARTUNIFIER operates with small apps called communication instances that can be deployed on any kind of computing device. These instances can be deployed on industrial PCs or on micro PCs being built even inside an equipment. All the instances can be operated in data centers or, and this will bring a lot of business advantages, directly within the cloud, which is eliminating completely the need to provide separate connectivity hardware. Why is this important? It is important because of this architecture, SMARTUNIFIER can be scaled from very small, even just covering the connectivity of one single production equipment, to very big, covering hundreds or even thousands of devices. Industrial connectivity is not only about providing communication interfaces between the shop floor and the cloud. It's also about managing and being able to deploy the required connectivity flexibly across the facility and within the enterprise. This is exactly what SMARTUNIFIER does, as illustrated in the given example with the latest reference architecture for SMARTUNIFIER within AWS Cloud. The green bullets you see are the various SMARTUNIFIER communication instances that can be deployed and operated at any location within an enterprise, on-prem, at the edge, even within production equipment and devices, or alternatively directly within the cloud. The deployment locations of these communication instances only depend on the given use case and on requirements or constraints due to customers' IT infrastructure. As a result, efforts and costs for the provision of industrial connectivity are drastically reduced, and highest flexibility in building up highly scalable connectivity infrastructures are given. Now, what are typical use cases where SMARTUNIFIER could be applied? Simply spoken, all use cases where industrial connectivity is required. This applies for various industrial domains like manufacturing, energy and utilities, smart buildings, smart cities, but as well, of course, for airport industries. This ranges from basic use cases like, for example, device monitoring, data distribution, data lake feeding, to more advanced use cases to realize Industrial 4.0 functionalities and services like facility heat map, real-time data analytics, and equipment self-service. Of course, also complex use cases like predictive analytics, artificial intelligence, machine learning, or production as a service might be supported by SMARTUNIFIER with its powerful and easy-to-use connectivity. In this respect, I'm as well looking forward to the next talk presented by Ingo Müller, who would illustrate an energy monitoring use case as a concrete example. With this final slide, I want to close my today's presentation, and I'd like to thank everyone for your participation. I would be very happy if my talk has created your interest, and hopefully it has become a bit clearer to you how cloud-based industrial connectivity could help you to boost your business processes as well. Now I'm looking forward to your questions later in the Q&A session. Thanks. And I'm handing back to Andy.
Thank you, Frank, for those insights. And actually, without losing much more time, I would like to hand over then to Ingo. Just maybe reminding you quickly that you can still raise questions and yeah, in the chat, and we will pick them up during the Q&A session later. So please use that opportunity and raise your questions and start an exchange later on. Quickly about you, Ingo. You're also a very much experienced colleague in this domain around manufacturing. I think starting in the 90s, where you did your degree in the UK around electrical and electronic engineering. You had various positions in IT consulting, working in projects like for Deutsche Post, so the German parcel service, Bosch and others, and joined T-Systems back in 2012. And now since 3 years, head of the Tribe Innovation Management and responsible for the development of strategic solutions actually around the manufacturing area. With that introduction, Ingo, I would hand it over to you, and the floor is yours.
Thanks, Andreas. I hope you can see the slides.
Yes, all fine.
Yes, all fine. That's very good. Thanks, Andreas, for the introduction. So, and also thanks for having T-Systems in the webinar. So you have heard a lot about the smart features of AMORPH solution, and also about the AWS services, but how can it all be brought together to have a business advantage? That is what I'm going to tell you in the next part of this webinar, by example of an energy management solution. But let me do a quick introduction to T-Systems first. So the T in T-Systems indicates that it belongs to the Deutsche Telekom enterprise, but T-System itself is also a large enterprise with almost 30,000 employees worldwide, and so we do have got a very large portfolio ranging from consulting services, system integration, application development, digital enabling, over advisory and operations, and also cloud services. In particular, I'm very proud of T-Systems being the IT service provider #1 in Germany and also in the DACH region. Furthermore, just in September, we have won the Automotive IT Congress IT Award by now the 13th time in a row, and also in the automotive industry, we are part of the Catena X Alliance network, and Dave has mentioned the Volkswagen digital production platform. We are also a partner of Volkswagen in that area and support Volkswagen in building up this platform. Now, I know there are quite a lot of participants from the airport industry as well, so I would like to mention that T-Systems has done a solution development in that field since 30 years, and worldwide over 50 international airports trust T-Systems solution, including the super airport Beijing Daxing in China. So now you know a bit more about T-Systems. Let's jump into the important topic of sustainability and as an example of our energy management solution. So if we have a look at the energy management as such, the situation and challenges, we've got increasing energy costs. Everybody knows that from his own household. Enterprises want to make use of funding opportunities and therefore need to have certifications. It is also about complying to future regulations and requirements, and also the customers are paying more and more attention to environmental aspects. And so enterprises, and I would like to focus on the manufacturing industry for the moment and come back to airport industry later. So the challenges enterprises in the manufacturing industries faced are the determination of the ecological influencing factors, such as energy consumption emissions of the entire production, and the data integration of production sites with their different systems, organizations, and applications, and also the derivation of measures for optimizations. So, and all of these challenges are quite hard to tackle for the manufacturing industry, but T-Systems has got an innovative solution to visualize and optimize the energy consumption across production plants. So, and this is an overview about the features of this solution. And first of all, there is the hurdle of getting the data at all. And you can trust, of course, the Deutsche Telekom and T-Systems to have the connectivity solutions from a technical point of view ready, like 5G networks, campus networks, and also multi-channel communication. So we can do that for our customer very well. And then on the software and the data level, you face the challenge that all the production equipment and the IT systems in the production, they are very different. They talk different protocols, and also they send their data in different formats and also in different structures. And at that point, the AMORPH SMARTUNIFIER is a great help to do the standardization. The SMARTUNIFIER supports various protocols also for airport industries, but also for the manufacturing industry, like MQTT or OPC-UA, and so it can communicate with all these equipment in the production and get the data, and then it standardizes the data from an individual format and structure to a standardized format and structure for further processing. Furthermore, to prepare the data, the application does a data normalization. If you think of an enterprise which has got a plant in Germany and maybe a plant in South America, you know that the climate conditions are very much different, and they influence also the energy consumption. So I can't directly compare the data and draw conclusions out of it, I have to normalize the data first to make them comparable. And our application does that by regression analysis. Furthermore, you want to take your measures for energy consumption reduction very early. So our application supports a forecast into the future. Furthermore, a very interesting feature that helps our customers in two ways is the anomaly detection. If you think maybe of a pump in the production plant, which has a very small increase in its energy consumption over a long period of time, you wouldn't see that as a human being, but our application can detect that and send an information to the worker, to the maintenance team on the shop floor, in order for them to have a look at this pump and do a maintenance job on it, or to replace the pump. And that helps in two ways. The one point is that you get your energy consumption back to normal again. And the second point, also very important, is that you avoid a failure of the pump, which might lead to an overall stop of production, which would be very critical. So this is a very important and interesting feature. Furthermore, all of these data and the results of the analysis are displayed in very easy to use and clear dashboards, some of which you can see below, but I come to some more examples afterwards. The application and its dashboards support your ISO 50001 certification in order for you to make use of funding opportunities. And from a technical perspective, our application can run in any cloud environment, especially also in the AWS environment, and also can make use of the AWS native services. So let's stick to the technology for a minute, and let's have a look at an overall sketch of the system. You can see at the bottom the different equipment in the manufacturing plant, and this is technically connected, for example, via a technology from Deutsche Telekom and T-Systems. And then the Amorph SMARTUNIFIER is running in the IT of the plant and communicates individually to all of this equipment due to its multi-protocol support. It then does the standardization on the data and then sends the data to the central platform, and within the platform all the data from all the plants come together, and there are artificial intelligence and analytics routines running on these data to process them and to visualize them in easy to use and clear dashboards. So speaking of which, let's have a look at the dashboards, and I've got a couple of examples. You can see these dashboards are designed with a filtering mechanism on the left-hand side and the graphics on the right-hand side, in this case a map where you can see the different locations within Germany of your plants, and you can see directly the current energy consumption of these plants. Especially you can use in this view an animation where you can see in an animated fashion the different energy consumptions over the history over time. From there, you can drill down, for example, in this dashboard to the level that you can see for a particular plant, the differentiation for the different shops. you can see directly that the paint shop is consuming the most energy. And from there, you might to get on to the cross-factory comparison. And there you can see that the filtering is more detailed. It goes down to a particular machine group and a machine. And on the right-hand side, you can see the energy consumption over time within a particular plant location. So furthermore, the last dashboard I would like to show you is the SEU dashboards. SEU stands for Significant Energy Users, and this is a particular focus of the ISO 50001. And in this view, you can see the equipment with the highest energy consumption on the left-hand side of this bar chart, and the others then to the right in the bar chart. So now I would like to leave the dashboards and have a look at how the application can be adopted and used in the airport industry. And there you would have quite a similar architecture. However, of course, the data are different, and also the data sources are different. You would have a look and collect data from the building as such, with its heating and cooling and lighting, which consumes a lot of energy. You would also connect to elevators and escalators in order to get the data, and also within baggage processing and so on. So these data are a bit different, but the architecture is the same. And again, the data are connected and processed by the SMARTUNIFIER, and then sent to the central data platform for further processing. And also visualization then in the different dashboards. I would like to mention at that point that it is important to put all these data also in the business perspective. And if we talk about the manufacturing industry, that would be KPIs like the number of produced part at a station in the plant or overall. And for airports, this is more KPIs like the passengers processed or the visitors in the airport. So here we would also connect things like the flow measurements of the airport. So let me wrap up with our solution integrated with the SMARTUNIFIER. You will achieve a transparency about your plants and about your airports as part of your sustainability performance, reduce the energy consumption, reach a combined ISO 50001 certification across the plants and airports, make use of funding opportunities, comply to future regulations, and become even more the customer's favor. So all this combined in a cloud-based solution by T-Systems. So thanks very much for listening. If you are interested further, you can contact me via Amorph or also via LinkedIn. And now I hand you over back to Andreas.
Andreas, I think you're muted still.
Thanks. Thanks for the presentation, Ingo, and the insight that you gave us around the energy topic. I think a very, very interesting and important topic these days.
Yes.
This actually brings me to our Q&A session, and I think we don't have that much time left, but I still wanted to pick up one question actually that we got from the audience. And I think this goes to you, Frank. It's a question from Dirk, handling about the SMARTUNIFIER landscape, and actually how is taken care of, who can see what information, as part of the established connectivity.
Yeah, thanks, Andy. Thanks, Dirk. I think this is a very good question. And to give you a quick answer, I mean, we can discuss this, of course, in more detail, is that SMARTUNIFIER typically is not by itself handling the access rights of data, but it routes, let's say, requests transparently to end systems. So typically, SMARTUNIFIER in that case would connect to an end system like a database or a data lake or an application where these access rights are handled, and then routes the answers to the sender of the message. I hope this answers your question.
Sorry, I was again on mute. I think that answers the question, at least at that level. And Dirk, if you want to have more details, please feel free to get back to us for having a more detailed session. We are running out of time. Actually, I would have still some questions in mind on my own, but I think I don't want to stress that too much today. So we are actually fine in time right now with the hour that we had. Very, very interesting insights from all of you. Really happy to have had you on board, and looking at these various aspects and views actually on industrial connectivity from the platform aspect, as well as that specific use case that you presented for the energy management. A final word maybe from you, Frank, if you would like, regarding industrial connectivity. Where does it go, or where are the advantages that need to be pushed now in the various markets that we see?
Yeah, I think especially is that what we address. So I think industrial connectivity in future will be much about being able to handle these many different heterogeneity and heterogeneous protocols in an easy way. I think it goes in a direction really to simplify things, not to program bidirectional interfaces, creating a lot of code, spending extremely high integration efforts, but have an easy way. So I think SMARTUNIFIER is a way to allow that with this low code approach. And then I think finally is also about decentralized architecture, because this is the only one which is able to scale from very small IT landscapes into very big ones. And especially with future cloud-based approaches like we have with AWS, I think this is even more important to have that kind of decentralized approach also for being able to realize more advanced use cases like, for example, condition monitoring, which requires handling of a lot of different data in a big scale.
Thanks. Can't agree more. Thanks for these final words. Again, very much thanks to our participants today. To Dave, I know it was very early for you starting the session. Thanks to Ingo, and for sure, thanks to the audience, that have joined us today for the webinar. It will be recorded. We will make this publicly available as well. So if you want to review or want to share that with colleagues, friends, whoever, please feel free. We'll share that link afterwards. And thanks again, and very nice rest of the day. And greetings from Amorph.